Your eye color isn't just appearance. It might be the hidden survival code your ancestors used to stay alive on Earth. I used to think eye color was one of the simplest things about us. Just genetics. Just appearance. Just another detail you inherit without ever questioning why it exists. But the day that assumption broke, it hit me harder than I expected. It started with something ordinary. I was standing in front of the mirror one morning, half awake, sunlight coming in through the window. My eyes looked darker than usual, almost heavy with color. Later that same day, under colder indoor lighting, they looked different, flatter, less alive somehow. That shift kept nagging at me. Not because of vanity, but because of curiosity. If the color could change in appearance so easily, what was actually happening inside the eye itself? And then a stranger thought crept in. What if this wasn't just about looks at all? That question pulled me down a path I didn't expect. I started reading late at night, research papers, evolutionary biology articles, studies on pigmentation and ultraviolet radiation. The more I learned, the more unsettling the truth became. Eye color isn't decoration. It's not random. It's not even primarily about beauty. It's a biological response to danger. Thousands of years ago, long before sunscreen, sunglasses, or modern medicine, human survival depended on how well the body could handle sunlight. The eyes, especially, were vulnerable. Too much radiation could damage vision, weaken perception, and slowly erode a person's ability to function in a harsh environment. And evolution, as it always does, responded with a solution. That solution was pigment. Melanin didn't just give the eye color. It acted like a shield, absorbing light, filtering harmful radiation, protecting fragile cells that allowed our ancestors to hunt, travel, and stay alive under relentless sun. Suddenly, something I had always considered cosmetic started to feel ancient, functional, earned. And once that realization settled in, I couldn't unsee it. Every pair of eyes I looked at afterward felt less like a color choice and more like evidence. Evidence of climate, migration, and survival written directly into the human body. Which led me to a question that still keeps me thinking. If our eye color exists because our ancestors needed it to survive, then what story is your color trying to tell? That question led me to the place where every human story about eye color begins, with brown eyes. The more I dug into the research, the more I realized that brown eyes aren't just common by coincidence. They are common because, for most of human history, they worked. They kept people alive in environments that were brutally unforgiving. When scientists talk about melanin, they often describe it in technical terms: pigment density, light absorption, cellular protection, but what I kept picturing was something much simpler. A shield. Not made of metal or stone, but built directly into the body. Imagine standing on open land thousands of years ago, with no buildings, no shade structures, no artificial protection. Just sky, heat, and relentless sunlight day after day. In that world, the ability to see clearly wasn't a luxury. It determined whether you could track animals, notice danger, or find your way across unfamiliar terrain. Vision was survival, and survival depended on protecting the eye from damage you couldn't immediately feel. Brown eyes carried a quiet advantage in that fight. The higher concentration of melanin absorbed incoming light before it could scatter inside the eye. That meant less glare, more stability, and clearer vision under intense brightness. Over time, those small advantages added up. People who could see better in harsh sunlight were more likely to succeed in hunting, traveling, and caring for their families. Their genes continued forward, generation after generation. What struck me most wasn't just the protection itself, but the elegance of the solution. Evolution didn't add new equipment. It refined what was already there. A deeper pigment. A slightly darker iris. A biological adjustment so subtle that most of us never stop to question it. Now when I see brown eyes, I don't see something ordinary anymore. I see endurance. I see design shaped by pressure. And I see a reminder that the most widespread traits in humanity are often the ones forged in the harshest conditions, quietly doing their job long before anyone thought to call them beautiful. But the more I respected the strength of brown eyes, the more one mystery kept pulling at me. Why would evolution ever move away from something so effective? That question led me straight into one of the most astonishing discoveries in human genetics. At some point between 6 and 10,000 years ago, a single human being was born with a tiny change in their DNA. Not a dramatic mutation. Not a new organ or visible transformation. Just a subtle shift in a gene called HER2 that reduced the amount of melanin produced in the iris. And from that one quiet genetic moment, blue eyes entered the human story. What fascinates me is how fragile that change must have seemed at first. Less melanin meant less natural protection from bright light. In the environments where our species first evolved, that would have been a disadvantage. So why did it survive? And more importantly, how did it spread so quickly across entire populations? When I picture early humans moving northward into colder regions, places where sunlight was weaker, winters were longer, and skies stayed gray for months, the possibility starts to make sense. In low-light conditions, allowing more light into the eye could have been helpful. Not dramatically better, but just enough to notice movement in the distance or navigate dim landscapes. Sometimes survival hinges on very small margins. Then, there are gray eyes, which seem to push this adaptation even further. They contain even less pigment, creating a softer, more diffuse scattering of light. The result is a color that feels almost metallic, cool, steady, and rare. Scientists believe this extreme reduction in melanin may have helped people adapt to environments where sunlight was scarce and subtle visual sensitivity mattered. But what stays with me most is the reminder that evolution doesn't move in straight lines. It experiments. It takes risks. A mutation that once looked vulnerable can become valuable in a new environment. And somewhere in that long chain of human migration, a small genetic change didn't just alter eye color. It reshaped how entire populations saw the world. And once I understood that evolution was willing to experiment, I started paying closer attention to the eye colors that seemed to exist right on the edge of that experimentation. Green eyes were the first to truly puzzle me. Not because they're simply rare, but because producing that color requires an almost delicate balance inside the body. Scientists have identified multiple genes working together to create it, each adjusting pigment levels just enough to land in a narrow middle ground. Too much melanin, and the eyes shift toward brown. Too little, and they drift toward blue. Green sits precisely in between, stabilized by a yellowish pigment called lipochrome that subtly reshapes the way light reflects through the iris. What struck me was how sensitive that balance appears to be. People with green eyes often notice that their color seems to shift depending on the environment, deeper in shadow, brighter in sunlight, sometimes leaning toward gold or gray. That responsiveness made me think about landscapes where lighting constantly changes. Dense forests, rolling hills, regions where seasons transform the world every few months. In places like that, adaptability might matter more than extremes. Not maximum protection, not maximum sensitivity, but flexibility. Hazel eyes seem to embody that same idea of versatility. Instead of a single uniform color, they carry a mosaic of pigments distributed unevenly across the iris. Under one type of light, they appear green. Under another, brown or amber. The first time I learned that this wasn't just an illusion, but a physical interaction between pigment and light, it changed the way I saw them. They felt less like a color and more like a system, something designed to respond to shifting conditions. Then, there are amber eyes, which carry a different kind of presence altogether. Their golden, copper-like tone comes from high levels of lipochrome with relatively low melanin, creating a color that remains stable no matter the lighting. It's a look we also see in many predators across the animal world: wolves, owls, eagles, species built for alertness and precision. The deeper I looked into these rarer shades, the more I realized that evolution doesn't always choose strength or sensitivity alone. Sometimes it chooses balance, unpredictability, and the ability to adjust when the world refuses to stay the same. And the more I thought about that balance, the harder it became to ignore the bigger realization quietly forming in my mind. Our eyes are not just features we inherit, they are records we carry. Somewhere along the way, this topic stopped feeling like a science lesson to me. It started to feel personal. Every color I learned about, dark, light, rare, shifting, began to look less like a cosmetic variation and more like a survival decision made long before any of us existed. Not consciously, not intentionally, but through generations of trial, pressure, and adaptation to environments that demanded resilience. When I walk through a crowd now, I catch myself noticing eyes in a different way. I wonder about the sunlight someone's ancestors lived under, the climates they endured, the landscapes that shaped the biology we see today. A deep brown gaze might reflect centuries under intense sun. A pale blue or gray might echo long winters and dim horizons. A rare shade might signal the delicate interplay of genes adjusting to a world that never stayed constant. What humbles me most is how quiet this history is. There are no monuments carved into stone, no written records attached to these traits. Yet the evidence is there, visible every time we look at another human face. So the next time you find yourself staring into a mirror, pause for a moment. Look past the color. Because what you're seeing may not just be part of your identity. It may be the living memory of survival itself, still watching the world through your eyes. In the end, what stayed with me most from this journey is how something as small as eye color can carry the weight of human history. The shades we see today are not random decorations. They are the visible results of survival, migration, climate, and adaptation unfolding over thousands of years. Our bodies remember what our ancestors endured, even when we don't. Every glance into a mirror becomes a quiet reminder that we are living outcomes of resilience. Not accidents, not coincidences, but stories, written in biology, still continuing through us every single day. The deeper lesson here is simple but powerful. Many things we take for granted in our lives have meaning and purpose shaped by long-term effort, pressure, and persistence. Evolution teaches us that strength doesn't always come from dramatic change. Sometimes it comes from small adjustments, repeated over time, until they become part of who we are. You can apply this idea to your own life right now. Progress rarely happens overnight. Growth often looks subtle in the moment. Learning a new skill, improving your health, building discipline, staying consistent when results are slow. But just like genetic adaptations across generations, those small choices accumulate. Over time, they shape your future in ways you may not immediately see. Patience, consistency, and adaptation are not just biological principles. They are life principles. Now I'm genuinely curious about you. What color are your eyes? And have you ever thought about what story they might carry? If you feel comfortable, share your answer down in the comments so everyone can read different perspectives and experiences. And if you found this exploration meaningful or thought-provoking, consider subscribing to the channel. Your support helps keep the curiosity alive and allows us to keep creating more stories that connect science to everyday life.